Before I start the video today, I just want to give a quick plug for a website that's up on your screen. Tristan and my name is Dan, have actually been making videos for all the sections, and you can access those videos and the PDFs of the notes of the videos that we make, even the ones that you see here, on that website. So just so another place for you to look. But the content for today is we're looking at interpretations of the derivative. So we've gotten really good with interpreting functions from section 1. So let's say I had a function that told me the cost of a turkey. So the cost of a turkey, and let's say it was in dollars, and it's a function of the weight of the turkey. And so let's say that weight was in pounds. All right? And so the notation for the derivative that we would have before is just f prime of w. And this doesn't really help us understand what the derivative means very much. But we're going to use this new notation, this Leibniz notation, that'll help us a little bit. All right? And so what we'll do is we'll start with our output letter on top, and we'll start with our input letter on the bottom. And you can kind of think of, remember the derivative is kind of like slope, so you can kind of think of deltas out here, right? It's the change in cost divided by the change in weight. But this notation actually is going to tell us to use lowercase d's. And what this keys us into is the units for our derivative. That my units are, it's just like slope. So I'm going to use my units from the top. I'm going to use dollars, and then I write a per, and then I use my units from the bottom. So dollars per pound. So let's use this new kind of technique for figuring out the units of our derivative, dollars per pound, to kind of help us understand some statements about the derivative. So I think it's probably going to be pretty easy to tell at this point, but food is on my mind. I want to go home and eat dinner. And the temperature of my roast, uppercase T, is going to be a function of time, lowercase t, and minutes, since I put it in the oven. And so I want to interpret these two statements. And so to do this, let's just get the units of our numbers first. This is a problem from 1.1, I believe. And so this 2 tells us that that's 2 minutes. This is 40 degrees. And so what does this statement tell us? Well, it says at 2 minutes, my roast is 40 degrees, right? And that's pretty cold, but it's probably because I just took it out of the refrigerator and I just put it in the oven, right? So it's pretty cool at that point. But how about this statement here? What does f prime of 2 equals 0.5 mean? So let's do the same thing with the units. So we have minutes here, right? But to get the units for this 0.5, let's write down our Leibniz notation real quick. And so what we'll say is the difference, the d uppercase t, so my temperature, divided by d lowercase t, and then when we specify a particular point in this notation, we're going to put a line. We're going to say at t equals 2 is equal to 0.5. And so this is going to help us get our units for this 0.5. So the units for this 0.5 will be the units on top, so degrees per my units on the bottom, minute. Right, so to understand this statement, we'll just kind of start the same thing. We'll say at my input, just like above, so at 2 minutes is kind of the first thing I write. And then we're still making a statement about the temperature of my roast, but not the same type one we were above, right? We'll say, we'll say the temp of my roast, so my output value. So at this input value, my output value is changing by, and that's where we put in what our derivative tells us, 0.5 degrees per minute. So there's 3 big kind of components to this statement. So at my input value, the temperature, so my output value, and then we know what it's changing by. So at an input value, my output value is changing by this much. We need to make sure we have the units there. So what about a type of statement? How do we interpret the derivative of a statement where they don't tell us what it actually is? So let's say I take the roast out of the oven at t equals 120. What will the sign of f prime of 140 be? And so to do that, let's kind of do the same thing we did up here, except we'll just leave part of it blank. So we'll say at 140 minutes, so the same thing, the temperature of my roast is doing what? It's going to be changing, but not by 0.5 this time, changing by blank degrees per minute. All right, and whatever I put in this blank, that's what tells me about f. That's what f prime of 140 is, right? And so what we've hopefully realized here, since I've taken my roast out of the oven, at 140 minutes, the temperature of my roast is going to be changing by some negative value. It's going to be decreasing, right? It's not getting hotter now. It's changing by, we could just say maybe negative 10 degrees per minute. Hopefully not that steep, but you get the idea that f prime of 140 here will be negative. Okay, but so that's a lot of what this section is. It's about interpreting and understanding derivatives. But let's look at an example that's more mathy, has more numbers. I know that's what you guys love.